Okay, so now that we kind of did a little overview of why we need a common denominator, add and subtract fractions, let me spend this video just doing some examples where we find the LCD, build up our equivalent fractions, and do our addition. So again, to add or subtract, what I need is the pieces have to be the same. So in number one, everything's broke up into sevenths. So you can imagine if we had a piece of pizza or a bar or whatever, it is broken up into sevenths. That's also broken up into sevenths. So my pieces match my pieces. So to add, we keep that denominator and then basically add up the numerators. So in this case, this was kind of an easy one since we already had a common denominator. 3 sevenths and 2 sevenths add up to 5 sevenths. So 3 pieces of 7 and 2 pieces of 7 add up to 5 pieces of 7. So that one was pretty easy because we already had an LCD. Moving on to problem number 2, we don't have an LCD. This problem is broken up in sixths and we're using 5 of those pieces. This problem is broken up in eighths and we're using 1 of those pieces. So we're a little not the same. So we have to figure out the LCD. Again, to find the LCD, there's several tricks of the trade, but what you can probably start doing is just listing multiples of 6 until you find one that 8 also goes into. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and then 8 does go into 24. So there is our LCD. So now I have to build equivalent fractions, right? So 5/6, what does that fraction look like equivalently with a 24 down at the bottom? So to do that, we'll multiply by 4 over 4, right? 6 times 4 is 24. To get my 1, right, because we're going to multiply by 1, I have to do 4 over 4. For 1/8, we need to multiply by 3 over 3. So this creates the fraction 20 over 24, and this creates the fraction 3 over 24. And so now 5/6 is equivalent to 20 over 24, and 1/8 is equivalent to 3 over 24. So now that I have everything in the same pieces, I keep those 24ths, and I basically just subtract my numerators. And in this case, we get 17 over 24 as our final answer for that. Again, please show me that step on your quizzes. I think it's a very important step. I will take points away if you don't show me that, and somehow you just go from here to there or here. This work is very important to me. So, matter of fact, I'll make a deal with you. If you guys get really good at it the first couple of weeks, I'll let you stop showing it to me. But for now, first round of quizzes, I'd like to see this equivalent fraction step. So thank you. For number 3, again, we have the same problem. We're adding, but the denominators are different. So we need an LCD. And again, if we kind of just start listing some multiples, 9 times 1 is 9. 9 times 2 is 18. That doesn't work. 9 times 3 is 27. That doesn't work. And then 9 times 4 is 36, which 12 goes into. Excuse me. So there's our LCD. So again, we need equivalent fractions that will be equivalent to 2/9 but have 36 down to the denominator. So the form of one I need over here is 4 over 4. That'll get the trick done for 2/9. And for 5/12, I believe that'll be 3 over 3. So again, please show me that step for the first couple of weeks. This now gives us 8 over 36, and this gives us 15 over 36. And now that I have the same denominator, I keep it and I add up my numerators. There's your rule. And so we have 36, and I think 15 and 8 comes out to 23. So 2/9 and 5/12 results in the fraction 23/36. So it's pretty much the same thing over and over again. Here for number 4, we're subtracting. The denominators are not the same, so I need a common denominator. And again, if we list some factors, I'm going to do the 15 this time, right? 15 times 1 is 15. 15 times 2 is 30, and there we go. 6 goes into 35 times. So there's our LCD. So what equivalent fraction can I build out of 7/15? Well, I need a 2 over 2 to get to the 30. And for the 1/6, I need a 5 over 5. So equivalently, this is 14 over 30, and this is 5 over 30. And then we keep that denominator, we subtract what's up in the numerator, and in this case we end up with 9 over 30. Okay, so the good news for number 4 here is we've done the subtraction by building our equivalent fractions, getting a common denominator, and subtracting. The bad news is we're not done. In these examples, they were all simplified because the numerator and the denominator did not share a common factor, but here 9 and 30 do share a common factor. So you can either use the magic trick, or I'm just going to go ahead and show the work. The common factor is 3, so 9 is 3 times 3, and 30 is 3 times 10. Dividing out that common factor, we have a final answer of 3/10. So this one was kind of a tough one, because not only would we have to build equivalent fractions, but at the end we had to simplify our answer because it wasn't simplified. It had a common factor on top and bottom. Again, the magic trick would have been just say, 3 goes into 9 3 times, 3 goes into 30 10 times, giving us 3/10. But there's the work. You decide how you want to do that. It's all about dividing common factors out. Okay, and then last but not least for number 5, 3/4 plus 1/6, and in this case the LCD I believe will be 12, but if we just go kind of 6 times 2 is 12, there it goes, they both go into that. So to get an equivalent fraction for 3/4, I would have to multiply the top and bottom by 3 over 3. To get an equivalent fraction for 1/6, I'd have to multiply the bottom and bottom by 2. And so we end up with 9/12 plus 2/12, keeping the denominator, adding the numerators, we end up with 11/12 there. So there's many examples of where we're adding and subtracting. Again, the key is we need the denominators to be the same. If they are the same, we keep the denominator and just add or subtract the numerators. If they're not the same, we go through some work to find our LCD, build our equivalent fractions, keep our denominator, and then add or subtract as needed depending on what the problem has. And there's basically adding and subtracting. So work on those rules, get them down, because we'll be using them a lot. And in the next video, what we'll do is we'll take a look at some other weirder cases where we talk about improper fractions and whatnot and using the same rules. So almost done. We're going to put these all together in some more weirder situations. So I'll see you guys in the next video. Well done.